Fantastic fourth graders. This is Mrs. Whaley and I'm back for week 5. This week we are going to continue focusing on being mathematically fluent in fourth grade. Here is our agenda for this session. First, we're going to go over the challenge from week 4. Then we will have a quick vocabulary review. Next, we will work on our math tasks for this week. And then at the end, we will have a surprise guest. Let's revisit the challenge question that Ms. Roberts gave you last week. Can you make 24 using all of these numbers, 9, 4, 1, and 2? You can only use each number once, but you can use any operation. What equations did you come up with? Here are a few of mine. 9 plus 1 equals 10. 10 times 2 equals 20, and 20 plus 4 equals 24. Next example would be 9 minus 2 equals 7. 7 minus 1 equals 6. 6 times 4 equals 24. And then the last one, 9 plus 4 equals 13. 13 minus 1 equals 12. 12 times 2 equals 24. Did you come up with some different equations? I'm sure you did, because there are at least 10. This week in 4th grade, we are going to review a standard you learned during Unit 2. You learned how to interpret a multiplication equation as a comparison and represent verbal statements of multiplicative comparisons as multiplication equations. First, let's review the vocabulary that you need to know in order to solve our problems today. Factors. Those are numbers that are multiplied together to get the product, which is the answer to a multiplication sentence. That multiplication sentence is called an equation, which is a mathematical statement that uses an equal sign to show that two expressions have the same value. And then our last word that you need to know for this week is multiplicative comparison. It's basically a statement that shows how two factors and their product can be read as a comparison. The general idea of a multiplication comparison is that the product is the result of increasing the starting number by a given factor. Let's look at our first problem listed on your worksheet. Write 2 sentences to describe this multiplication comparison. 8 times 7 equals 56. If you are able to pause the video, please do so now so that you can solve this problem on your own before I show you my answer. Here's my answer. 7 times as many as 8 is 56, or 8 times as many as 7 is 56. You could also begin with the end, with the product, and say 56 is 7 times as many as 8, or 56 is 8 times as many as 7. Did you get all of those? Now let's look at the second problem listed on your worksheet. How could you prove that 42 is 6 times as many as 7, and 42 is also 7 times as many as 6? If you are able to pause the video, please do so now so that you can solve this problem on your own before I show you my answer. Okay, there are several ways that you can solve this problem. Let's look at one of them now. I made an array of 42 blocks in 6 rows of 7 blocks in each row. The equation that matches this picture is 6 times 7 equals 42. You could also rearrange this array into 7 rows of 6 blocks in each row. The equation that would match that rearrangement would be 7 times 6 equals 42. You could also draw diagrams or use number lines to solve this problem. Now let's look at the third problem listed on your worksheet. Draw and label a bar model to show a number that is 6 times as many as 9. If you are able to pause the video, please do so now so that you can solve this problem on your own before I show you my answer. Okay, let's look at my answer. Does your bar model look like mine? Did you draw 6 boxes and put the number 9 inside? Did you label the answer 54 like I did? 6 groups of 9 equals 54. What if I'd asked you to draw a bar model to show a number that is 9 times as many as 6? What would change? What would stay the same? Now let's look at the fourth problem listed on your worksheet. Reed and Mackenzie are reading the same book. Reed read 56 pages. He read 8 times as many pages as Mackenzie. How many pages did she read? If you are able to pause the video, please do so now so that you can solve this problem on your own before I show you my answer. Okay, so the first thing I did with this problem was that I broke it into 2 steps. So in step 1, I began by organizing the information I did know. I knew that I needed to figure out how many pages Mackenzie read. I knew that Reed read a total of 56 pages and that he read 8 times as many pages as Mackenzie did. So look at my picture. In step 2, the first thing I did was write the multiplication equation that I was trying to solve. 8 times something equals 56. And I realized that since I knew that the total that Reed read, I could create a division problem too. 56 total pages that Reed read divided by 8 times as many as Mackenzie equals the number of pages that Mackenzie read. Next, I drew 8 empty circles and then I put 1 tally mark in each circle until I counted to 56. I ended up with 7 tally marks in each circle. Now I know that Mackenzie read 7 pages. How is this problem different from the times as many problems you've been solving? In this problem, division is used to find the answer. The answer is not the product, but it is the missing factor. And so you'll see 56 divided by 8 equals 7, or 8 times 7 equals 56. Now let's look at the last problem listed on your worksheet. Circle each answer that can be solved using the equation 6 times 4. This question requires you to solve each letter in order to circle all of the correct answers. If you are able to pause the video, please do so now so that you can solve letters A and B of this problem on your own before I show you my answers. So for A, Randy walked 4 times as many blocks as Meredith walked. Meredith walked 6 blocks. How many blocks did Randy walk? And then B, Mr. Kaiser donated 6 boxes of books and 4 boxes of CDs to the library. How many boxes of materials did he donate? Let's look how I answered A and B. So Meredith walked 6 blocks and Randy walked 4 times as many blocks as she did. I know that I need to multiply the number of blocks that Meredith walked by 4. 6 times 4 equals 24 blocks. Randy walked 24 blocks. You should have circled A because 6 times 4 equals 24, and that's what you were looking for. B, Mr. Kaiser donated 6 boxes of books and 4 boxes of CDs. This question asked me how many boxes he donated in all. I know that I need to add. 6 boxes of books plus 4 boxes of CDs equals 10 boxes donated. You should not have circled B. Now let's look at questions C and D. C, Emma ate 6 pancakes for breakfast. Denver ate 4 fewer pancakes than Emma. How many did he eat? D, Lance spent $6 at the fair. His sister Paige spent 4 times as much as he did. How much did Paige spend at the fair? If you are able to pause the video, please do so now so that you can solve letters C and D of this problem on your own before I show you my answers. Okay, let's look at how I solve C and D. In C, Emma ate 6 pancakes and Denver ate 4 less than her. I know that I need to subtract. 6 minus 4 equals 2 pancakes, which means that Denver only ate 2 pancakes. You should not have circled C because this is not 6 times 4 equals 24, which is what you're looking for. D. Lance spent $6 at the fair and his sister Paige spent 4 times as much as he did. I know that I need to multiply $6 times 4, which equals $24. Paige spent $24 at the fair. You should have circled D. Wow, you guys have been working really hard and I'm so proud of you. Don't forget that these activities are available for you to print from Knox County Schools website, or you can pick them up, print a copy on Wednesdays at the meal distribution sites from 10 a.m. to 12 p.m. One last thing. I thought I would change it up this week and end our time with a guest reader instead of a challenge.
Hi kids, my name is Mrs. Payne and I teach 4th grade math at Bonnie Cape Elementary School. And I just want to say that we have missed seeing your all smiling faces during this extended break. And since I'm a math teacher, sometimes I like to read books about mathematicians. And I found one that I would really like to share with you. It's called Counting on Katherine. And this is a biography about Katherine Johnson. Counting on Katherine by Helena Becker and illustrated by Dow Pumiruk. Katherine loved to count. She counted the steps to the road, the steps to the church, the number of dishes and spoons she washed in the bright white sink. The only thing she didn't count were the stars in the sky. Only a fool, she thought, would try that. Even so, the stars sparked her imagination. What was out there? Katherine yearned to know as much as she could about numbers, about the universe, about everything. Katherine's boundless curiosity turned her into a star student. She was so bright she skipped 3 whole grades. She catapulted right past her brother. He wasn't too happy about that. By the time she turned 10, Katherine was ready for high school. But back then, America was legally segregated by race. Her town's high school didn't admit black students of any age. Katherine burned with fury. She wanted more than anything to keep learning. There was still so much to know. Count on me, Katherine's father told her. By working night and day, he earned enough money to move the family to a town with a black high school. Katherine loved high school. She was good at every subject, but math was still her favorite. She dreamed of becoming a research mathematician, making discoveries about the number patterns that are the foundations of our universe. In those days, though, there were no jobs as research mathematicians for women. Professions most available to them were teaching and nursing. So Katherine became an elementary school teacher. She liked her job, and she loved her students, but she never stopped dreaming about exploring numbers. In the 1950s, the U.S. government's National Committee on Aeronautics, NACA, hired thousands of new employees. It even started hiring black women as mathematicians. Katherine heard about the mathematician jobs. Her heart raced with excitement. Perhaps her dream would come true after all. But when she applied for one of the positions, she was told they were already filled. Katherine had to wait a whole year until new spots opened up. Her patience paid off. She got the job. A few years later, the Soviet Union sent a rocket ship into space, launching a space race with the United States. NASA was rolled into a new space agency, the National Aeronautics and Space Administration, NASA. Katherine now found herself at the heart of America's space program. She worked as a computer. Electronic computers were not widely used yet, calculating long series of numbers. All the computers were women. They were given the tasks that men thought were boring and unimportant. That didn't bother Katherine. She knew that without her contributions, the spaceship couldn't reach its destination or safely return to Earth. Here's why. Sending a rocket ship into space is like throwing a ball into the air. At first, the force of the throw sends the ball up, up, up. But as its energy runs out, the ball's path curves back toward the ground. Where it lands depends on what angle it was thrown and how high and how fast it flew. Because math is a kind of language, Katherine could ask those questions. How high would the rocket ship go, and how fast would it travel? Using numbers. And numbers would provide the all-important answer. Where would it land? To find out, Katherine plotted the numbers she calculated on a graph. When she joined the points together, they formed a curved line. At one end of that line was Earth at the time the rocket ship landed. At the other was where Earth would be when the ship landed. Katherine's reputation for accuracy and strong leadership skills, she was known for asking plenty of questions, got her promoted to Project Mercury, a new program designed to send the first American astronauts into space. Mercury's missions were going to be dangerous. So dangerous that even the project's star astronaut, John Glenn, refused to fly unless Katherine okayed the numbers. You can count on me, she said. Glenn's spacecraft, Friendship 7, orbited Earth 3 times and returned home safely. Glenn became a national hero. Katherine was promoted again. Now she was asked to calculate the flight paths for Project Apollo, the first flights to the moon. Count on me, she said. On July 20th, 1969, the Apollo 11 astronauts walked on the moon. Their feat was celebrated around the world. More triumphs followed. Apollo 12 rocketed to the moon in November 1969. Apollo 13 launched on April 11, 1970. But on the third day of Apollo 13's flight, the worst thing happened, an explosion in space. Could the crippled spaceship make it to the moon? And if it didn't, would it be able to get back home to Earth? The 3 astronauts on board were in grave peril. Commander Jen Lovell told Mission Control, "Houston, we have a problem." Back on Earth, Katherine Johnson got a phone call. Her flight path calculations would have to be done all over again, and perfectly. It would be the toughest challenge of her life. Katherine told Mission Control, "You can count on me." She rolled up her sleeves, took a deep breath, and began doing the math. She worked hard and fast. A few hours later, Katherine's calculations were finished. The flight path to return home would take the ship around the far side of the moon. From there, the moon's gravity would act like a slingshot to zing the ship back to Earth. To get home, the crew of Apollo 11 would have to follow Katherine's course exactly by burning off fuel at precise intervals. If the astronauts made a mistake, their ship would drift through space forever. Katherine waited anxiously to hear the astronauts' report. Finally, it crackled over the loudspeakers. "We've got it." Apollo 13 was back on track. Katherine Johnson had done it. She had brought Apollo 13 home. She was no longer the kid who dreamed of what lay beyond the stars. She was now a star herself. I am so thankful that you allowed me to read this story, counting on Katherine to you tonight. We miss you and we can't wait to see you soon.